turned in or be finding them during the minute of silence here. Our quiz this morning will be no calculator. So get those things turned in and clear off your desk, please.
I think I wrote my name on them. Did I?
You're sorry though, you're supposed to be in your seat when the bell rings. What? So, that's one. You need to be in your seat ready to learn.
Oh. Wait, is it 14, 15? Is that right? You don't want
What do you need, Oliver?
I'm not sure if I got that. I don't remember. I can check myself. What was the unit one quiz like?
That's what you're about to take in a minute.
Oh, what were the things that, okay, turn 11, 12, 13. Okay, sorry. I was looking at 14, 15.
No, that's what we're doing today, not what you need to turn in today. Okay, I guess we are not doing minute of silence this morning. Or the intercom are totally broken right now. So again, I need these 3 assignments before we get started here. So make sure you have 11, 12, and 13 turned in, please. If you haven't turned them in yet, double check your names on them before you come put them in the box. Go ahead, clear off your desk, and then I'll let you get started. And if you are still finding those papers, I'll come back to you. But if your desk is cleared off, I'll let you get started. Okay, so not extremely long. I need to feel rushed. There are some questions on the back.
Which assignments?
11, 12, and 13. It's under bell work.
Gotcha.
Okay, you guys got about 2 minutes if you're still looking for your work. After that, it's going to be late. You need to get your binders put together as part of the expectations here. Yeah. Thumbs up. You can start your quiz. It's now or it's late. There's 3 assignments. Okay, get your binder put together. Yeah, were you not here Friday? Okay, which one did you do, 12? On number 13? Okay. You need to go grab a 12 over there. You can work on that. Would you rather take the quiz today and then make up 12, or do you want to do 12 and then make up the quiz?
12 looks like
It was extra practice on improper integrals, which is what we did on 11.
No, that is 12, sorry. The one I can get that's on notebook paper is 12.
Okay. So you didn't have 13?
I didn't have 13.
Okay, that's fine. It's very short.
Okay.
It's mostly me just telling you what is fair game for the quiz.
Okay, cool.
But I would understand if you want to do that first.
Yeah, let me do this first.
Again, so I think it's pretty straightforward about what it's expecting you to do, although you can always ask, I guess. I'm going to point out that the first page questions are 2 points each. You also have questions on the back page, but those are only worth 1 point each. So no partial credit on the 1 point questions. Either it's all right or incorrect. And then on the 2 point questions on the front, I can do partial credit. But of course that depends on how much you show me and how much of it's correct and all that kind of stuff. So also keep in mind, notice it doesn't say integrate this with U sub, integrate this with partial fractions, integrate this with integration by parts. It's not telling you what to do, as I warned y'all last week. But you know there's probably going to be at least one of each of our BC topics on there, which is partial fractions, integration by parts, and improper integrals. You should expect at least one of each of those, if that hint does anything to help. Okay, as you finish, you should number this as 14, please. I won't pass this one back until they're all made up. So you are all here today, so your class probably won't take too long, but I don't know about fifth period. Fifth period is also a BC class. So depending on, yeah, it looks like Camden's skipping in fifth period today. So it might be next week before I get these back to you. But when you finish, especially if you have extra time, you might double check your work. You might think about, is there any way to check these without a calculator? Anything you can do to help correct some of your mistakes before you turn it in. Of course, this won't be worth a ton by the end of the semester, but keep in mind right now you don't have any major grades in the grade book. We have minor grades and major grades. So temporarily, this one will count 60% of your grade. So. And then you can just come turn it into the basket as you're done. And then wait quietly, please. You're welcome to work on something for another class while you wait. And then when they're all finished, I've actually got a choice for you what we'll do after the quiz today. Thank you. For those of you that do finish a bit earlier than everybody else, I've got your graded homework papers. I'm gonna put them here in the first period drawer. This is where I always put graded papers. So if I pass back paper someday and you're absent that day, I put yours in here. So if there's nobody else over there and you turned in your quiz, feel free to take out the papers with your name on it. If there is somebody over there looking, you can just come back when they're done. Yeah, someone told me it was wrong language, so.
That's fine.
Yeah, that's fine. In the future, just email me if you see that, I can fix it quickly. I put you on prime time to make every quiz.
Send the basket.
Okay, I wasn't sure because I didn't see it.
sure your name's on it though. Okay, those of you that are finished, you'll need to find something quiet to work on, please.
Mr. Townsend.
I was an idiot and did it in pen, so it looks like a little messy. Should I like redo
Yeah.
everything on a separate paper?
Do you have your answers sorted?
Yeah.
Okay, I can probably figure it out.
Okay. It's true that when you finish something, like after it's late, you get half credit back, right? Or is that
Up until the assessment.
up until the assessment? Yeah, I finished this. I got 5 out of 10 because it was incomplete.
Okay, I need this before we start the quiz next time. This was the assessment.
Oh, I see.
I need to see that you did it before.
Okay.
I'll give it to you this time.
Okay.
Wait, what assignment was that, 11?
Let me see.
You ever turn in 10?
We have not turned in 10 yet. Guys, y'all need to find something quiet, please. Still got people working. Okay, for those of you still working, that is fine. You can go ahead and keep on going. Take a few more minutes. But we've got about a little over 30 minutes of class here, so I'd like us to do at least one of two things. So if you are still working on your quiz, you'll just need to watch this part of the class recording so that you can get this caught up. And so I'm going to give you an option here. Would you give one of each of these?
Yes, sir.
We got people quizzing. Please don't. Let's not make any unnecessary noise. So you're going to get two handouts here. One of them needs to be numbered as number 15. It is our next BC topic. And other than having to memorize the formula, it's actually easier than our other three BC topics we've done thus far. It's about arc length. Nice. So we can, and we're going to just do it.
Number 15, you said?
Not that one. So one he's passing out. This one doesn't have a number yet. So we can either start the arc length formula one. I'm just going to take a simple majority and I'll let y'all decide. Or, as a group, you guys can work through. I printed out some review questions. Just 8 questions. But these are from a past math ACTM competition. So if you want to do that one, that's fine. But again, there's only 8 questions there. And I would like you guys to take the lead. So what I mean by that is, if you want to do that one, somebody needs to tell us how they think they should work out question 1. And then somebody different should explain why they think the answer is what it is to question 2. And then if there's something that nobody knows, then I'll fill in that one. So we'll end up doing both eventually, so it's not a big deal either way. I just felt like I would give you guys the choice. So raise your hand if you would like to start the next BC topic, which is on arc length. Okay, keep it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, if you'd rather do the 8 ACTM contest questions. Okay, save the contest questions for later. let's look at arc length for a minute. Now again, we're not going to get all the way through this. Let me print this out. But I guess you can start reading it. Give me just a second to get this printed out on my sheet. I'm just waiting 1 second for this internet to catch back up. Are y'all talking about the ACTN questions?
Yes.
Oh, you didn't vote for those.
I did not, because I did not do them, but
We're going to do them eventually. Most of them are pretty easy.
yeah. You are? Nice. Cam can't go because it's cold. I need you to bring the energy. Me and Lucas are friends.
Stop raising your voices, please. Okay. Sorry for the delay there. Okay, so when we talk about arc length, let's all get focused on, this is assignment 15. I have this one numbered for you. As you guys saw earlier though, if you were trying to find your assignments to turn in, you only have 15 assignments in your binder right now, maybe 16 if you count the other handout I gave to you that wasn't numbered. Now's the time to get organized. It's only going to get harder and harder as you get 30, 40, 70 handouts in your binder. Don't just keep kicking that can down the road. Okay, but for arc length, when I say that, what you should be thinking of when you've heard of arc length is like in geometry class, if you want to talk about the distance all the way around the circle, what was that called?
Circumference.
Okay. And then if you wanted to talk about the distance part way around, what do you call that?
Arc length.
Very good. Y'all did learn something in geometry. So you're used to thinking of it as the distance part way around a circle, but really it can be any kind of curvature. So if we know the distance formula, which is where you subtract the x values, square it, plus subtract the y values and square it, and then take the square root of all of that, that's what's called the distance formula. What is the distance formula derived from?
Pythagorean theorem.
Very good. If you know Pythagorean theorem, instead of thinking of lengths A, B, and C, you thought about points. You got x1, y1, x2, y2. That's distance formula is just a different form of Pythagorean theorem. Who was your geometry teacher?
Mrs. Bone. Yeah.
Good.
Well, I just guessed on that one though. It
Oh.
seemed kind of right.
Okay, well, I was almost proud of you. Okay, so what we're going to do is we are going to try to estimate something like this. Like, what is this distance of this line? So basically, you know, if you were just traveling along it, how long would that distance be? Or if you straightened it out so that it was horizontal or vertical, and then you could just measure it. So we could think of this as like, we could take a couple of points, and if we think of one distance, it would be like this. Actually, I guess it would just be like this, which is a terrible estimation. The distance of this red line is way off of the distance of this. But what could make it closer is if instead of doing one line segment to estimate it, we could maybe do 2 line segments to estimate it. Do you see how even going from 1 to 2, all of a sudden it starts to be pretty close? Okay, so in theory, how many line segments should we need?
Infinite.
Good, so more line segment, the better the approximation. So we will be thinking about how that approaches infinity. Now, there is a proof for this on the next page that I will point out to you when we get there. But this only works if you're talking about a smooth, continuous curve. It's got to be continuous. And by smooth, that means no cusp. So if you want to know the arc length, one way to add up an infinite number of something, in this case I want an infinite number of line segments, is with integration. So we can say, I want to know the distance between A to B, so we will integrate from A to B. And then it turns out that the length of that arc segment comes from the integration of the square root of 1 plus the derivative of f squared. Now, luckily, again, I've got a proof on the next page for you if you're interested in where in the world is that formula coming from, why does it work that way. But luckily for you guys, you don't have to prove that in this course. You don't have to understand where it comes from. You just have to be able to use it. So the good news is, if you can memorize it, then you're already pretty close to being able to do what you need to do. So let's say I want to find the arc length of this function, the distance from 1 to 4. So again, it's like if you graphed this, you took the distance from 1 to 4, you took that curve, you straightened it out, you lined that straight segment up into next to a ruler or a meter stick or something, and we're trying to figure out what is that length. Okay, but the calculus tells us, well, why don't you just integrate 1 to 4 of the square root of 1 plus the derivative squared. So of course you're going to have to slow down, and most of the time you're going to have to do the derivative here. So this looks like power rule and product rule. If we bring the power down, lower the power by 1, and multiply by the derivative of the inside for chain rule. Chain rule is 2x. Okay, we'd like this to look as neat as possible, so this could turn into let's see, this 2 could cancel out this 2, this 3 could cancel out this 12, that would make for a fourth. There's an x, and then this is the square root of x squared plus 8. So that's what the derivative is, and I need to plug in the derivative squared here. Now, if this was a fairly simple integration, then I'm sure they would ask us to do this by hand. But this is not one that we would be able to do, or even if we could do it, we wouldn't want to do it if we didn't have to. So we just need to remember how to put this in our calculator. So I'm not going to type it all out for you because I've already done this, but just make sure that you remember second window is one place to find this. Just like in AB, BC test will expect you to be able to do derivatives at a point, which your calculator can do for you, and integration if it's a definite integral. So you would select that, type it in the way it looks. Of course, you have to make sure you type it in exactly correctly, and your calculator will give you that answer. I actually did work this one out by hand, but it came out to be 33/4. So there's really two things to these. There's memorize the formula, and two, you probably have to take the derivative that you need. It's probably not going to be done for you. And that's about the bulk of what we need to do for these questions. So let's look at another one, and then I'll show you the proof. And then I'll ask you to try a couple. Okay, question 2. Set up an integral that represents the length of the curve of sine x for 0 to pi. Use a calculator to find this limit. Okay, so based on the formula, what's the first thing we need? Braden, what's the first thing we need?
Set the bounds of 0 to pi.
Okay, what are the bounds going to be?
0 to pi.
Okay, so we want to know the length from 0 to pi, so we're going to integrate from 0 to pi. The formula says we're supposed to integrate what?
The square root of 1 plus the derivative of y squared.
Correct. And then dx, of course. So you probably will have to take the derivative. And then if you throw all of that in your calculator, and of course you're squaring this correctly, you're not squaring the x, you're squaring the whole thing, you've got parentheses there or whatnot, it comes out to be 3.820. So not much work to be able to do that. Okay, so if you're interested in the proof, again, I didn't really type up this proof, this was their proof. I just stole these because I like some of their example questions. But you can see they start with the distance formula, they rearrange it a bit, they make it look different, and then if you follow them enough, then you can see where the integral comes from the definition of an integral. You can see where the derivative piece comes from, all of that. So if you're interested in the proof has 11 steps to see why that works the way it works. But again, I don't expect you to know that. But I know some of you are interested, so. Okay, I would like you to try this. Just one question will be the only one we do on the board, and I'll ask you to do a couple of these before we find the stopping point for today. But try this number 1. Write out what you think it should be. Write out what you's going in the calculator. This one says do not evaluate, so just set up the integral. You don't have to evaluate it. Okay, did you say you were going to integrate from 0 to 5 pi over 6? And you're integrating 1 plus something, or the square root of 1 plus something? Okay, and then the part that you need to slow down on is this something is supposed to be the derivative squared. At least this is an easy derivative to get. This is an integral that would give you the length on the sine curve from 0 to 5 pi over 6. So again, either this integral will be easy enough you could do in your head, or they'll let you have a calculator, so that's not usually the challenging part. Memorize the formula and just know when to use it. Okay, I would like you guys to try, if you would please do questions 2 and 3. 2 and 3 are the only two I'm asking you to do, and you've got about 15 minutes to do those. And I'd I've got the answers up here. So we'll talk about those in a minute. So just questions 2 and 3, and then that would be a good stopping place. But I want you to put a full effort into those 2, please. Okay, what do you think the answer to number 2 was? I heard a C, I heard a E. Any other guesses? I'm hearing multiple C's. Okay, so when you look at all of this, if you're interested in what y equals, which is what most of the choices are for the curve, what part of this are you interested in?
4x.
Okay. So this 4x squared is supposed to be what part of the formula?
The function squared.
The function squared?
Or derivative of the function squared. That's what.
The derivative of the function squared. So if you unsquare each side, or square root both sides, you get that. And then to try to figure out which one of those is y, how do you go from y prime to y?
Raise the power.
Okay. Now there should also be a plus c, right?
Yeah.
And then maybe this 0.16 helped with that?
Yeah.
If you plug in 1/6, then you get 1 plus c equals,
6.
oh wait, that's supposed to be on the curve, not the derivative.
Oh.
Oh, my bad. I integrated from here to here, so this shouldn't have had the derivative. Okay, so when x is 1, y is 6, so that means c is, so y is x squared plus c, and c is 5, so there it was. But you had to know to look at that part of the formula and know that that part of the formula was not y squared, but the derivative of y squared. And otherwise it wasn't too bad. Okay, question 3, you did need a calculator, so I'm going to just tell you what the answer was, and if you did not get this, or if you didn't have enough time there, try to type it back in the calculator a second time. And if you're still not getting that, check with your neighbor to see if you've got it set up correctly. But make sure you feel good about that one as well. And then that will be our stopping point, so then you're welcome to pack up. And I'll share a puzzle with you guys in a few minutes.
How long do you think that would take? Like, you think you could do that in 20 hours? You could do that in 20 days? It was only 20 hours to work for? You think? You do it in 2 days. What's your cram?
We were just talking about the homework for tonight. Only like 20 hours.
Oh, that's not bad. Not bad at all.
Dude, I wish we said virtual.
I mean, if I start that time, I get home with them.
No, I don't wish I was virtual. Virtually, you get your work done so quick. You just like cram it out.
Yeah, but that was social.
Yeah, that's true. But, no, I don't wish I was virtual. But it's just, that's the
No, virtual.
Virtual is
But you literally have no social life.
Yeah, that's
Yeah, you really have them.
That's why you do virtual school and then join a sport.
I go crazy with virtual.
Well, yeah, but those were years.
Hold on.
I mean, there are a lot of people who are virtual and are with so.
Yeah, it might not be.
So it's not causation.
I know two that are normal.
There's some that are just
I'll be on one virtual.
He's chill,
He's a bit weird.
No, but I have a friend who's virtual, and he's already done like half the semester in Apes, and like 1 year and a half.
Yeah.
Like, he started like a week and a half late, and then Apes is also an easy class, but
I took virtual health 2 years ago, and I had to take it.
Yeah, I had some friends take both personal finance and economics in the summer. It took them like 3 days to do all of
are
it.
you serious?
Yeah.
That's crazy.
It was like 6 hours a day, so.
So they were working.
That's a lot of work. I was
That you have to be disciplined on that.
We're gonna do that.
That's like
easier way to
2 entire semesters before.
I would have done that, but.
I guess if you know you're walking in and getting one done.
Yeah. So like, I think with that, how much time do we?
It's not that quick, because like that takes like an entire year. 6
So
hours times
much.
3 days.
What else depends on quality?
Yeah, that's true. 6 hours times 3 days.
You're not learning it here.
It's 18 hours.
You waste so much time at school.
That's really nice.
Well, you chose to like put a lot of time. You waste more time for the chem. You took Dr. Carlos.
We could just be working on the house with this thing now.
That's if I didn't have to go to school.
That's what it's about.
Yeah, so that gives us more work.
I wonder how long this will.
That's true. The quicker we work, the more work we get. We need to work slow.
She also just
Yeah, he says it's in the first
How's that?
Did that, but it was.
So don't worry about it. I mean, I would watch it the first 5 minutes.
You don't wanna
and be like,
Yeah, you're right, I don't want to. Yeah, you're right. I don't want to.
What do you look like? He doesn't want to play mini golf.
It's like there's like
The IHS is doing something. He would do the whole like
Okay, here's the puzzle for everybody today.
sixes and this night.
I remember you baking entire unit and that like.
Six isn't one of them.
It's not 7 3 8, guys.
Yeah, I have today.
Yo, like having your just.
I know it's not 7 3.
Oh shit.
Two.
Yeah, I'm testing back on my fifth grade too. 3 2 8.
It can't be.
0 2 4.
I
He said,
Zero and no, it's
I did.
Fuck.
I did the fourth.
There has some popcorn. It can't be that. Honestly, like, the starter fast. Flabbergasted was walking out of lunch. Oh, it's in their office.
this one tells you it's zero again. And then it's
Are you doing anything else?
So I guess we got like that.
yeah, it's 024 or 021.
One of the.
0, 1, 2.
I feel like one should.
Well, it's 0 and 1.
I don't know.
It's 0, 2 or 0, 2. 0, 4, 2.
Why are you trying to trick us?
1, 2.
Wait, no, 0, 2, 1.
I'm gonna go 0, 2, 1. 0, 6.
For real.
I posted the answer and explanation on Google Classroom.
0, 6, 2.
It sounds like I heard the answer, the correct answer at least once, but there's lots of wrong
0, 6, 2.
answers in there too.
0, 4.
Oh, it is the 0, 4.
I was like,
No.
it can't be 6.
Wait.
Because 2 is the correct again. It's 6, 1, 2. Here it tells you it's not in the right one. So it has to be.
So that's
Oh,
That's correct.
Yeah, 0, 4,
Oh.
that's it. 0, 4, 2. Good work, guys.
0, 4,
I like that.
Wrong position.
Yeah, usually. Just say that.
I thought.
But it's high vision.
0, 4, 2.
0, 4, 2.
Dex, but then 0, 4, 1, I said.
Oh, it's a good point, bro. Yes. On your 19 point quiz, you kind of them right.
At least not. I'm pretty confident with that. I don't remember like anything else that happened during that test not blocked out.
Oh no, it was just like the one you focused on.
Every day I go home and I sing
The
this.
other ones I was like, yeah, I remember.
Dude, I'm serious.
Bro.
Into the beginning of the year, I was
Yeah.
had a lot of new people just.
Yeah, I'm sure the guys already, you know, walking in class and I was like, see your eyes, ready to.
Oh, yeah. Well, part of it is the fact that
Yeah.
well, it's over the 5 days.
Well, I didn't know about that.
Yeah.
But they
Also, we got.
Like,
And I get to take a nice, long, warm shower. And then I get like 2 more times
the tiniest
Have a good day.
They're good. I mean, just good enough to sit in a good Yeah. They're good enough. No, just a little piece of it. So, it'll be tough to. We have to play well. We have to play well. Yeah. But we beat them last time like